Disproving the Lagrange mathematics in economics. The Standard Lagrange. This is a Standard Lagrange problem. It sets out to maximize utility, subject to a budget constraint. Utility is a function of x1 and x2, while the sum of the two costs must not exceed a given amount, C bar. The symbol lambda, attached to the constraint, is called utility of money, or Lagrange multiplier. The standard procedure to solve this problem is to make use of the calculus that at the tangent point, the slope of the indifference curve is equal to that of cost line. Together with the budget constraint, the two equations solve for the two inputs, x1 star and x2 star. If the Lagrange L is 0, the utility calculated from the solved inputs is said to be the constraint maximal 1. Instead of utility, output can also be maximized, given cost constraint. Reversely, cost can also be minimized, given output or utility constraint. Lagrange mathematics looks powerful and versatile. Disproving the Lagrange equation. Suppose utility is a function of only one input, for example coffee. The Lagrange equation is simply this. If the first cup gives you 10 utils, the second 8 utils, etc. Utility is a positive function with diminishing slope. The constraint does not appear here, for it is always 0. For C bar equals to P1x1, the Lagrange equation reduces to this. Now, you can pursue maximum utility at will. Suppose utility is also a function of x2. The Lagrange equation returns to this. As an expansion from this graph, the two-input model geometry should be a 3D quarter dome, with U being measured in the third dimension. Again, the constraint does not appear here, and the Lagrange equation reduces to this. Contradictorily, constraint maximum has no constraint. Without any constraint, the Lagrange equation is disproved. The proper equation for spending a budget. The Lagrange equation is disproved. But suppose you do have a constrained budget to squander, correct or not? What should the proper equation be? Here is the proper one, for the one-input version. Lambda is kept until later transformation. Of course, you will spend the whole budget, so it becomes. No calculus is needed. The Lagrange L is not necessarily 0, but is usually negative. For the two-input version, the proper equation is where x1 bar and x2 bar can be any value, as long as their combination used up the budget. Budget constraint in practice. Most public projects are funded by given budget. So people simply squander the whole budget and deliver only limited output. That is a practical disproof of the Lagrange teaching. Budget constraint is an excuse. In the private sector, insufficient fund can easily be financed by borrowing, if the project is profitable. In other words, budget constraint is only an excuse for business failure or bad mathematics. Freedom. Lagrange's constraint seems to reflect the fact that the world's resources are no longer free. But such an interpretation is incorrect. Given laissez-faire, you are free to hire any optimal amount of input, as long as you pay the input price, including interest cost, implicit or explicit. Hence, the Lagrange people have misunderstood and abused the word free. Freeing Lagrange from any constraint. As stated, the Lagrange people have misunderstood the word free to impose budget constraint. In place of the false ones, the equation below describes the proper way to spend a constrained budget. But constrained spending is wasteful and detrimental. Instead, here is a truly free spending equation, one without any constraint. And the cost line appears also in the total utility graph. Though negative, cost is an important part of the objective function. It helps enhance utility. Hence, it is not so intimidating, as the Lagrange people had thought and feared. According to this graph, marginal utility is the slope of the total utility curve, and its equalization with the slope of the cost line derives the marginal condition, mu1 equals to lambda p1. This condition delivers the optimal solution of x1, say x1 star. However, at x1 star, utility does not look like reaching its maximum. Contrary to the Lagrange implication, the optimal solution does not imply maximum utility, so what does it imply? Suppose drinking coffee enhances your negotiation ability in a positive diminishing way. Suppose also that negotiation result has measurable units with a price of m. Define lambda equals to 1 over m, and multiply m to the above equation to obtain this. This new Lagrange equation reveals the difference between monetary negotiation result and coffee cost. That is, your profit from drinking coffee. And profit is maximized where the slope of the curve is equal to that of the cost line, or mu1 equals to lambda p1, or at x1 star. Hence, the optimal solution implies maximum profit, not maximum utility. Now, negotiation result had better be denoted by a more secular symbol, for example, y. And monetary marginal result, mu1, had better be called marginal revenue, mr1. Then, mu1 equals to lambda p1 becomes mr1 equals to p1. Finally, pi replaces the Lagrange L pi, and profit function replaces the Lagrange equation. It is apparent now that profit is the objective, and utility or output is only one of its components. Though possible, zero profit is not always optimal. Remember, P1 should include interest cost. When it is the inverse of output price, lambda is not marginal utility of money. This equation reflects the true freedom described above. The two-input version. In the model with two inputs, the above equation expands to this. This equation derives two partial conditions, mr1 equals to p1 and mr2 equals to p2. For example, since each is a function of another variable, the two conditions form two loci. Simultaneous solution, or the intersection of the two loci, delivers the overall optimal input and output. For example, disproving the Lagrange equation 2. When utility, revenue, is a positive function with diminishing slope, its maximum is infinity. Imposing a cost line will result in a subjective function with a finite maximum. Maximum profit. When profit is truly subject to 1, the Lagrange equation is further disproved. Disproving the Lagrange geometry. As mentioned, the proper configuration for the two input case is a 3D dome. The correct approach to solve any problem is to simultaneously combine numerous orthogonal cross-sectional images, like MRI, to get the full understanding of the situation. In contrast, the Lagrange geometry, with the pretentious existence of the constrained cost, is a distance picture from above. But such a view is inaccurate. It cannot tell, for example, that there is a gap between revenue and cost, or one between cost and revenue. That gap, representing profit or loss, is a matter of life and death for every business. Hence, the Lagrange geometry is distorted and dangerously misleading. In retrospect, this MRI reveals that a higher utility level, and hence a higher indifference curve, may actually mean a larger loss. Disproving the Lagrange calculus. The Lagrange calculus uses this graph to derive this equality, where the left-hand side is called marginal rate of substitution, while the right-hand side economic rate of substitution. However, when the indifference curve and the budget line are not physically tangent to each other, such an equality is meaningless. That is one thing. Secondly, when they do come into contact, such a contact is actually an intersection, where mu1 or 2 is not equal to p1 or 2. Then, the MRS-ERS equality, if any, is not optimal. Thirdly, the Lagrange people may have used the two partial conditions to form the equality. Though this formation looks optimal, its intersection with the budget constraint, while sacrificing the simultaneous optimality, results only in something between the two partial optimalities. In other words, the Lagrange solution is not even partially optimal. Hence, the Lagrange calculus is also totally disproved. Consequences. When its equation has no constraint, when its geometry cannot tell profit from loss, life from death, right from wrong, when its calculus does not derive even partial optimal solution, when it has misunderstood and abused freedom, when profit is the truly subject to equation, the Lagrange mathematics should be eradicated. When the Lagrange mathematics is eradicated, all theories based on it must also be removed, including consumer theory, the theory of firm, international trade and, in particular, welfare economics. Conclusion. This paper topples the Lagrange kingdom.